All right, so as we're moving into independent samples t-test, I'm going to approach this in the same way that I was presenting the information for the one samples t-test. I'm going to explain to you what it's used for, and then we're going to work through an example. Here we go. So what is an independent samples t-test? The independent samples t-test determines whether there's a statistically significant difference between the means of two unrelated groups. It's used when you want to compare the means between two separate populations. So in one sample t-test, you're comparing a single sample to a population. In an independent samples t-test, you're actually comparing one sample to another sample. And these two samples need to be unrelated. They're not connected to one another. Independent samples t-test can compare outcomes between control and experimental groups, or it can examine differences between naturally occurring groups. So in an example of an experiment where we can have a control group and experimental group. If, for example, we are comparing, students who attend embedded tutoring versus those who don't attend embedded tutoring, we can also control for, as researchers, how many times someone attends embedded tutoring. What's the difference between a group who attends one time versus two times versus three times, right? And we can create different experimental groups based on those different factors. That is an example of an experiment. In a non-experiment, I'm going to refer back to the example at the start of this presentation where I introduced you to the idea of running some sort of analysis between black students and Asian students and their GPAs. That's an example of a non-experiment because I, as the researcher, cannot control what someone's racial identity is. They are reporting that to me, and from that I am then placing them into groups based on these identities. But I'm not looking at someone and saying, okay, well, you are this racial identity or that racial identity, so on and so forth. So those types of naturally occurring groups are where we get non-experiments from. So in independent samples t-test. So let's take a look at gender and work-life balance. Let's say a sociologist wants to determine if there's a difference in work-life satisfaction among people with different gender identities. The research question ultimately becomes, is there a difference in the reported work-life satisfaction between men and women in dual-income households? Now, as the researcher, I'm the one who's identifying that I want to focus my research on men and women. If broadly we're talking about different gender identities, then I can include trans people in here, I can include queer people in here, and that would change, which group I'm trying to compare against another group. For this one, I decided to focus on men and women in dual income households. So our independent variable is gender, our dependent variable is work-life satisfaction. Since we're comparing two unrelated groups, we focus on sample means. And you'll see a little bit more of what that means when we get to the next slide on study design. So, the researcher randomly selects 52 women and 45 men from dual income households who are going to participate in this particular study. Each participant completes a work-life satisfaction survey using a scale of 1 to 100. Let's say that for the men, we calculate an average of 68.4, a standard deviation of 12.5. Let's say for women, we calculate an average of 61.7 with a standard deviation of 13.2. I want to reiterate here, we know how to do these things. We know how to calculate mean. We know how to calculate standard deviation. We're just skipping some steps because I'm not focused on those calculations for this particular component or of this part of the class. So our null and research hypotheses. Remember I shared that for each test, they're going to look slightly different. In the previous one samples t-test, we were saying, all right, the mean is going to be, the population mean from the sample is going to be exactly the same as the population mean from the survey data. In this case, we're saying that the populations that each of our samples represent are going to be the same for our null hypothesis. So if I'm comparing work-life satisfaction of men to work-life satisfaction of women, there's no difference if the population work-life satisfaction is the same between both of those groups. So that's a null hypothesis, no significant difference. On the other hand, we would write this as the population equal sign with a slash through it to indicate that the population average for men is different than the population average for women. And that's where we would indicate significant difference between these two groups. We'll set the alpha level. Researchers determine I'm giving you an alpha of 0.05. So how to calculate independent samples t-test. So remember, we need to calculate a T ratio, degrees of freedom, identify critical T ratio, and compare the calculated T ratio to the critical T ratio. Based on the prompt, we know that the N for group 1, so when we see the little subscript numbers, so numbers that are a little bit smaller off to the side, it's called subscript. That's representing sample 1. In this case, sample 1 is our men. We have 45 men in our sample. We have a mean of 68.4 for the sample 1. We have a standard deviation for sample 1 of 12.5. For women, we have a sample size of 52, a mean of 61.7, a standard deviation of 13.2. So for independent samples t-test, our next step is to calculate the standard error. And the formula looks like this. We have S1 squared. So that may look a little bit complex, a little bit complicated, but what this is effectively telling us, if we remember that S by itself represents standard deviation for a sample, S squared represents the variance of a sample. So the 1 here is only trying to let us know that this is for sample 1. So we want to take the variance of sample 1, divide it by the sample size for sample 1, and then we're going to take the sample size, variance of sample 2, and divide it by the sample size of sample 2. So I will say here that the capital S here is just a mistake. It should be lowercase. It still represents the variance for sample 2. In order to calculate the variance, remember that when calculating standard deviation from variance, we take the variance and square root it to get a standard deviation, which means we can do the inverse process in order to calculate the variance based on standard deviation. So if we take 12.5 and multiply it by itself, we're going to get this variance for sample 1. If we take 13.2, multiply it by itself, we get variance for sample 2, and that would go here. Each of those are going to be divided by their respective sample sizes. While I'm telling you the process, I'm not expecting you to do this. The other piece is after doing the division between the respective samples, variances, and their sample sizes, we then add those two numbers together and square root that value, right? Whatever that sum is, we would square root that. For this, we can just move ahead. So we would then calculate our T ratio using this formula. Notice that we are subtracting the means from each of the samples. We're not subtracting a population mean from a sample mean. This time we're taking the sample mean of sample 1 and the sample mean of sample 2, and then we're going to divide that by this unbiased estimate of the standard error that we calculated. We also have a slightly different degrees of freedom formula for independent samples t-test, and this is because the independent samples t-test incorporates 2 different sample sizes. So the degrees of freedom formula for this accounts for the differences when combining both of those samples together. Our standard error would ultimately be 2.61. Our calculated T is equals 2.57, and our degrees of freedom is 95. We would use table C to identify the critical T ratio. Remember that you are looking for where those 2 points intersect. A degrees of freedom of 95 is not represented on table C, so we would default down to a degrees of freedom of 60. Find where degrees of freedom 60 intersects with alpha of 0.05, and that's going to take us to a critical T of 2.00 and then maybe 2.002. We're still making the comparison. I put in the little asterisk just as a reminder that you're supposed to be comparing to an absolute value, but we're effectively still looking for, which is furthest from 0. We determined that our calculated T is further from 0 than a critical T. Remember that critical T serves as the boundary. So at a boundary of 2.0, our critical T ratio is further away from the mean than that in the critical region. That's how we determine significance. We are rejecting the null hypothesis. Reporting results for independent samples. An independent sample, so again, I'm going to read this as it is, just point out some really important details, and then, just kind of keep it moving. So, an independent samples t-test was conducted to examine gender differences in work-life satisfaction among dual-income households. Men with a mean of 68.4, standard deviation 12.5, reported significantly higher work life satisfaction than women with a mean of 61.7 and standard deviation of 13.2. How do we know that it's significantly higher? Because our mean for men is higher than our mean for women, 68.4 compared to 61.7. Again, we're not just looking to see if differences exist. We see that there's a difference, but we want to know through this test whether or not that difference is significant. And by the results of our comparison of our calculated T to critical T, we determine that there is in fact significant difference. We have a comma, and then we incorporate that formula, right? Where we have T of 95, we have our degrees of freedom here, equals our T value, 2.57, a P of 0.05, that is based on our alpha level. These findings suggest that despite sharing dual income status, men and women experience different levels of satisfaction with their work-life balance, with men reporting scores approximately 6.7 points higher on average. And that's just taking this mean, the mean of men minus the mean of women. I didn't incorporate any implications here. It's not necessarily a requirement. When it is that I want you all to incorporate, think of an implication for your research, I will ask you for it. This is the most basic kind of paragraph in APA format for reporting results that you can include. And if you did this, that's full credit, right? If I'm not asking for implications and you wrote me something like this, you're good to go. If I ask for implications, make sure you incorporate that. Oops. Okay, so interpretation and implications. Since 2.57 is greater than 2.0, we reject the null hypothesis, conclude that there is a significant difference in work-life satisfaction between men and women in dual-income households. Some implications of this could be that we need to do more research into gender differences in household responsibilities. Is there an imbalance in your household responsibilities that is leading to this difference in satisfaction between men and women? Are there workplace policies that might affect genders differently? Could there be something about the workplace culture, whether that be a matter of workplace culture or actual, written policy within the business that is, presenting differences for work-life satisfaction? Are there cultural expectations around family and work roles that are shifting how work-life satisfaction is gauged among people with different gender identities? And could this be indicative of structural inequalities in career advancement and career advancement opportunities? These are all different ways that we could think about what the implications of this research are. Now, if this research, as it relates to gender differences in work-life balance, or if, studying how a neighborhood might engage in community involvement differently, if those things are interesting to you, then that's where you as a researcher have the opportunity to do more research. Doing one piece of research is never like the end of it, right? Research has been conducted for a very long time, is going to continue to be conducted, and there are opportunities for you to participate in this. You don't have to wait until graduate school when you're conducting your own research. See if there are opportunities for you to get involved in things around you that are interesting to you right now.